Okay, so today we are starting radioactivity. Oh god, you cannot see. But I'm so happy to write on the black background today. So let's get started with the white. So the topic which we are going to discuss is the radioactivity and the complete process. Let's start with if first thing we have the atom. And everyone knows that the atom is the simplest or the smallest unit. Even this is the basic terms I hope everyone knows, but still I've seen many people writing a smaller unit is like a smaller part, a smaller unit is known as atom, but still you are wrong. Why? Just because before after smaller, like we have studied in English that small is the verb forms. So we, if I'm just writing smaller, there might be some people, like any one of you, might be thinking that there must be another smaller thing than the smaller, which would be known as smallest. So if I write smallest atom, this means after that there's no any term. This is the last part, which is the smallest. So that's why smallest is the perfect word to use here. I know this very common question, like very common. I've just asked just because I've seen people do use it like that. That's why I just said. So yes, atom. Okay. So atom. First thing we have two types of atom, not two types of atom but the two phenomena we have. First is natural. Second is chemical. So natural is simply like the nuclear reaction, we can say. Natural, the term tells that would be without a chemical uses. So natural reaction. Natural reaction and natural reaction change is known as the natural phenomena, or we can also say that the nuclear properties or the nuclear properties or also the change. Wait, nuclear properties or no, or change, not, or let me just have color, or change in number of proton and electron. Change in number of proton and neutron. Sorry if I just spoke electron, but that would be neutron here. Neutron and proton, atomic number simply. And then with the chemical phenomena, which would be the change in the orbit, and we can also say that the change in valence orbit is also just because of the change in valence orbit is also in the chemical. How? If I've taken any Na 2 8, like for suppose I've taken any element, carbon 2 and 6 here. So the outermost part is known as the valence electron. Okay, outermost is known as the valence electron, not electron but the valence shell, valence orbit. So this chemical change can be in the valence orbit as well as in the outer orbit. Okay, here chemical will be used, or there will be chemical reaction, simply not chemical use but the chemical reaction chemical reaction. Okay, then we have the chemical reaction or the chemical change as well, or we can also say that a change in electrons. That's why I did not discuss electrons there, because in natural we have only uh, proton and neutron. Okay, but in this we have change in electron, just because you can see if first one is having two electrons, second is having six. This is the oxygen example. Okay, for suppose we've taken any element and 2 6. So if I will reduce, if I make it 5, so this means there's change in electron. There will be no change in proton and electrons, because they are in the nucleus. Before that was the nucleus,